So we have this example here, and we are talking in terms of the angular variables of the wheel. So this guy is at rest, and the initial theta I is 0, the initial time I is 0, and the initial angular velocity is also 0. With this condition, the driver presses the gas pedal, and when he does that, he gets an acceleration of 2 radian per second square. It's not 2 meters per second square, it's 2 radian per second square, because angle units for angle is radian. And he does that for 10 seconds, or not 10 seconds, let's say 4 seconds. Let's make it 8 seconds. And let's assume that there is no air friction. If there is no air friction, then there is no friction in fact, then we are not losing anything anywhere. Okay, this is the angular acceleration, which happens for 8 seconds. Once the velocity is increased, the driver keeps driving this for another 16 seconds, and then he slows down in the next 16 seconds again with a deceleration of -1 radians per second square. Question is, what is the distance traveled if r equals 0.5 meters, where r is radius of car, not car, radius of wheel. Okay, so how should we solve this? Well, we can certainly talk everything in terms of angle, and then find the distance traveled. So first of all, let's see how much angle traveled. How much was the angle which was traveled? Let's calculate that. Okay. Also, with these variables, these initial conditions, we can write omega f equals alpha t f, theta f equals half alpha t f square, and omega, well, there's one more, but probably that won't be used, but just for the sake of completion, the third one will be omega f squared equals 2 alpha theta f. Okay, now we really can't really include all the variables in these equations. We have to go step by step. So from here to 8 seconds, then 8 to 16 seconds, and one more 16 seconds. So let's see what's happening here. Here omega I is 0. What is omega? Let's just talk in terms of omega. What is omega here? How to calculate that? Well, we can use the first equation, which gives the relation. So if omega I is 0 and alpha is 2 and tf is 8, because this is t equals 0 and this is t equals 8, whatever you want to call it, I or f, but that's the idea. It took 8 seconds. So this whole so if multiplying alpha, which is 2, with 8 gives you 16 radians per second. Okay, and here the velocity stayed constant, because here alpha was 2, here alpha was 0, so here also omega is 16 radians per second. How about here? Well, actually this is only for the first section, because we already know the equation. For this section of the journey, we can write omega f equals omega I plus alpha t, because here omega I was 0, so this, with omega equal to 0, we get this equation. So this belongs to this section. These are reduced equations. I'm not writing the whole equations. Okay, what is omega f? We have to calculate what is omega here, or omega, whatever you want to call. We are just interested in the angular velocity. And what is omega I? Omega I is the velocity here, because we are talking about this section, which is going to be 16 minus alpha is -1, and 16 there's a minus because of this minus is because of this minus, multiplied by 16, that gives us 0. So angular velocity goes back to 0. So car comes to rest. Okay, now we have the velocities also. How should we calculate the distances? So let's calculate this distance. To calculate this distance, we know we can use this particular equation. So theta I is 0, and theta f, or if you want to call this theta, is going to be, use this equation, the second one. So it's going to be, let's use it as scratch paper, multiplied by alpha, which is 2, multiplied by tf square, which is 8 square, and that gives us 64. So this is 64 radians. Okay, how about this? What is theta here? Well, you see, along the journey your acceleration was 0 and velocity was constant. So the angle traveled in this particular section is going to be the angular velocity multiplied by the time taken. So theta here will be 64, which is already there, plus, I'm just using these the 3 equations we talked in the last lecture, nothing more than that, plus velocity we already have calculated to be 16, and 16 multiplied by 16 gives 256, and this gives us 320, right? Okay, let's talk about this. Now in this section of the journey, we know that there is a deceleration, so we can use the formula that theta f equals omega I t minus half alpha, let's keep this plus half alpha t square. This is the equation, kinematic equation. What is theta f? Well, we can also add actually theta I to it, just to write the complete equation, plus omega I t plus half alpha t squared. So I'm writing different equations because I'm doing things in my head sometimes, but the moral of the story is that all I'm doing is just using those 3 equations, that's it, and applying it on different sections. So theta f is going to be, what is theta I? Is 320, plus what is omega I? Now omega I is what is the angular velocity in the beginning of the section, which is 16. How long it took? Well, it took 16 seconds in this part of the journey, multiplied by 16, minus half into 1 multiplied by t squared. How much it took? It took 16 seconds, so it's going to be 256, and that gives us 320 plus 128, and that is nothing but 448 radians. So if 448 radians was the angle traveled by the car, we know that the arc traveled is going to be r times theta, and all the arc which was traveled actually went in moving the car forward, because if you travel this amount of arc, the car is going to move forward by this distance. So this is what, 0.5 multiplied by 448, and that is 224 meters, right? So that is one example, and we'll talk one more example in the next lecture.